have a reference population where we have full sequence data. We can impute this into the reference population where we only have about 60k chip data. I've done this on the Duroc population that we talked about earlier, so this is some of the same animals. I had, in total, we sequenced about 115 animals. Some of these were landrace, and that was not really helpful for imputing the Duroc population, so I haven't got them in this slide. It's only the 90 Duroc purebred pigs that we sequenced. We had an average step of at minimum 10 times, which means that each side of the genome we will have about 10 reads for each site. And we use that to call SNPs. So we go from a high number of raw reads. We do a lot of really interesting things here that you don't really want to hear about. End up with almost 30 million potential variants, which we then filter. We remove SNPs with very low minor allele frequency because we can't really tell anything about them in a population this size. Make sure that all of them have only 2 alleles. Make sure that we have sufficient reads to actually call the variant. Mapping quality, they're not too close to windows, and then they're in high binary equilibrium. Oh, you might want to know we ended up with 11 million SNPs, which is quite a lot and time consuming when you want to impute, so I only had a look at chromosome 1. We created a pseudo 6K chip, which means we called the variants that were on the chip from the sequence data, and then we imputed from the chip on chromosome 1 data up to sequence variation. So that was, let me see, from the just over 6,000 markers that we have on chromosome 1 on the chip, up to just under 1 million variants that we have in the sequence data. And then we did a correlation between the SNPs that we found from the sequence and from the, the SNPs that we found in the sequence and the SNPs that we find in the imputed genotype. And we get mean accuracy per individual of 0.7, and we're not really happy with that, so we want to improve. And we have some strategies for that. We need to have more stringent quality and math filters for sequence data, which might help if you only have, if you only impute alleles that have high frequency. We could try to select SNPs that are more accurate, and then only impute to them. Sort of the same. We need more sequenced reference animals. That is definitely going to improve things. And a strategy is also to genotype a larger reference population using a high density chip that's just coming to the market at the moment with 700K, which could help imputing to sequence a lot, going from only about 33,000 markers and up to around 700,000. And then use this first impute up to the chip sequence and then impute further up.